Hello, everyone. Welcome to this week's protocol meeting. We have a couple caps to discuss today, and I'll start by presenting cap 67. I'll share the link here. So this cap is about emitting events in Stellar in the same format that we see in Sorbonne for Stellar assets, so that a user can use the stream of events to track balances. And this cap covers three separate higher level changes that are listed in the abstract of the cap, and I'll first go over the two smaller changes that make some semantic fixes to the Stellar asset contract events for compatibility with SEP 41, which is the token interface SEP. So the first is that we're going to stop emitting the admin on the mint and clawback events. The admin is an implementation detail of the SAC and does not belong in the event. The admin doesn't even exist in SEP 41 as a concept. The second change is that we're going to update an edge case with regards to transfers to and from an issuer. The SAC was written in a way that matched classic payment semantics, where a transfer from an issuer mints the asset and a transfer to an issuer burns the asset. The issue is that in these two scenarios, we still emit a transfer event instead of the appropriate mint or burn event. So this cap just proposes fixing that to emit the correct mint or burn event instead of the transfer event. So I'll pause there real quick if there are any questions about those two changes before I move on to the bigger change at hand. All right, then I'll move on to the third and most significant change of this cap, which is emitting an event in the same format as the Stellar asset contract for any asset movement. And this means that a Stellar operation that results in the movement of an asset can emit a transfer, mint, burn, or clawback event. And we're also adding a fee event to represent the fee paid by the source account. So the cap specifies what the events for each operation will look like, but I'll just mention some interesting points. So a trade that occurs either through an offer operation or a path payment operation will result in two events, one for each side of the trade. And the two parties on both events will be the source account of the operation and the owner of the offer. And these events can be transfer events, but they can also be instead be a mint or burn if the issuer is involved. We're also adding new SD address types to be able to represent the claimable balances and liquidity pools as from or to addresses in these events. And this allows us to represent movements to and from these entries. Yeah, so Silence asked, can you explain removing the admin from the SAC mint and clawback events? So currently on the mint and clawback events of the SAC, not in SEP 41, the admin is one of the topics of the event. But this isn't necessary, and the concept of an admin is not required for a token. Exactly. Yeah, it's not. We're not removing the admin from the SAC. It just says the topic. We're removing it from the topic of the event. All right. So yeah, we're also, in addition to those two new address types for kind of claimable balances and liquidity pools, we're also adding another SC address type for MUX accounts, so that these new events can pass along the MUX information if a MUX account is used in the operation or transaction. It's also another thing to share screens. So I'm actually not presenting this in the order that it shows up in the cap. This is just some points that I thought were interesting. But if you look at cap 67, these points should be listed there, right, with more detail. Then, yeah, so I wanted to mention that these new events will not be hashed into the ledger and therefore will not be part of the protocol. And we also will emit these events from Genesis if you replay from Genesis. And something to keep in mind here is that there was a bug in a very old protocol version where XLM was minted and burned, and we will emit events that will allow you to reconcile those balance changes. And finally, we will be reworking the format of TX meta with the transaction meta v4 that generalizes the events and separates them by operation. previously the events were formatted in a way where it was very specific to Soroban, and the fact that Soroban only has for a single Soroban transaction, there's only one operation, but the transaction meta v4 generalizes that. And the plan is to provide a config flag that enables the emission of this new meta format. Okay, so let me look through some of these questions. So will this resolve the issue with a locked issuer, SAC having an admin? Still can do things the issuer can't. Locked? No. So I think what you're sounds. I think what you're asking is if you change the admin and you lock the issuer, the admin. Okay, ignore that. Yeah, the admin can still do whatever it wants to. What else? Does backfilling mean that replaying with these new events enabled will emit meta v4 for all ledgers rather than just post 23? Yeah, that is the goal. And that should work. I mean, we probably have some stuff to work through there, but if we want to emit these events from the beginning, then that has to be meta v4. Let's see. All right, so mux addresses and memos. So yeah, one of the issues is, so the cap addresses the mux partially by forwarding the muxed addresses into the events. But there is another question about memos that I'll link this discussion topic from Nico. It's relevant. And at a high level, this amounts to considering a solution where you can group an arbitrary memo with a group of events, and this will allow you to solve some issues we've had with in the past with regards to the design of memos. But yeah, I don't know if Lee, if you want to discuss this a little bit more. That's something. This concept is something we still have to discuss.
Yeah, g'day. Yeah, so yeah, Nico may want to. I know this is sort of. I feel like his idea, so he may want to speak to this as well. But there, we have the separate. We have another cap 64 that we're not actually discussing today. That's um doing some things with memos. It's touching memos and where they show up, where they will show up in tooling, and making it possible to do a Soroban transaction with a memo and have that safely included in the signature. So that's cap 64. And something that Nico was bringing up with this cap is that, right now we're in this moment where we're making some significant changes to events, or we're doing a lot of work around events. And doesn't make sense. We have to sort of we sort of have to get close to memos because we've got this issue with muxed addresses. And right now cap 67 in a very non-controversial way is just suggesting that these events now might contain addresses that are mux addresses. So we're just going to pass it through. So if you do a payment operation that's got a destination of a mux address, that address field in the Soroban event could be a mux address. It could be an M address instead of a G address or a C address. And I think that is like very non-controversial. It's sort of like straight line what I guess we would sort of expect the cap to do in this situation. But we have this history where, once upon a time there was memos, then there were mux addresses. Right now the ecosystem is pretty, there's, both get used in the ecosystem. So both are getting used by exchanges. But when you look at the data tells a somewhat confusing story because this is memo field, there's this mux address, they can be in the destination. Technically, sources can also be MUX addresses. And Nico was sort of suggest. I don't know if I don't know if this was actually a proposal, but he was suggesting like, do we do something more here? Do we make these events in this moment more opinionated about what the memo for this event is? And do we do something like, if there's a transaction memo, this event has a memo, or if there's a destination of a MUX address, do we pull the memo out of the MUX address and we say, well, actually, that's the memo for this event? Because to some degree, like, the ecosystem has to do this somewhere. And right now it has to do this downstream. The ecosystem tooling has to make a decision about where these events come from. And in the future, like right now, memos, there's like MUX addresses are only a classic thing. Memos only occur at the transaction level in CAP64, but in the future, uh, like how do you attach memos to like other groupings or transfers if there's transfers being bundled together? Um, yeah, sorry, I'm not sure if I'm actually doing a great job of summarizing this. There's like a lot here.
Yeah, it's definitely something that still needs to be thought through. But I guess the question is, uh, should we explore, yeah, addressing that issue in CAP 67? It sounds like
Yeah.
we should, at least at a high level. Okay.
I think we should, and I think what Nico just posted in the chat is a really succinct way of for the why we should consider it now, and that is that CAP 64 is forcing the memo to be exposed to downstream systems for Sovereign events, and so it makes sense since this cap is very focused on that consistency between classic and Sorbin and fixing it across those two dimensions of Sorbin versus classic, SAC versus SAP41. It makes sense to discuss now.
Yeah, makes sense. Okay. Orbit asked this question, why did we decide to extend the meta with events if these events can be computed dynamically from the existing meta? Seems like redundant data in the meta. And this is something we actually discussed internally. I believe George actually mentioned this. They have single source of truth rather than risking bugs downstream, reinventing the wheel in dynamic compute. Also, Lee, do you have? I saw you unmuted yourself. Do you want to address this?
Yeah, I can speak to this. The uh, A large part of this is that when we look at the tooling that we have today, so we have Horizon, which takes a lot of what's in the meta today and creates this data model for people to consume. This new data model for people to consume, and then Stellar RPC was designed with a different approach, where the Stellar RPC really exposes the raw network data and tries to introduce as little as possible in terms of its own data model on top of that. And one of the reasons that Stellar RPC was designed that way is that you can go to, you can take contract events that have come out of Stellar RPC and they look the same way as if you go and take meta out of core, or if you use Galaxy to generate a data lake of meta. Like the events look the same way in all these different places, except if you go to Horizon. Horizon has its own data model, and it has that effects data model, which is very different. So um, the idea between the idea around like how, like why bring these events to classic and all the stellar asset contract and the classic operations is to create this like one unified view that appears everywhere, that looks the same everywhere that the data occurs.
Okay. Hopefully that answers that question. But if not, let us know. I think Lee, you mentioned another thing about another question about asset names on the topic of the events, right? Because the
Yeah,
SAC
I think
currently. Go ahead.
maybe before we move on, it does sound like
Okay.
Orbit has some things to say. I'm
Okay.
wondering, Orbit, do you want to speak to?
Yeah. Hello, everyone. Just wanted to add my 2 cents on this. We've been successfully reconstructing everything from transaction meta XDR on the client side. Basically, our ingestion pipeline in Stellar Expert is built on top of the library that we built specifically for this purpose. And we had a conversation with the Horizon team before, like several years ago, I think, where I proposed to actually remove all these excessive data tables like effects and everything like this, because all of it can be reconstructed on the client side. Of course, there are very specific issues like the memo case Lei covered before that. But maybe we can just like conduct some research on it, and maybe the Parson library we already have, and which have been tested for years, and which works with Classic and Soroban. Maybe it's enough because on the client side, people can just use it directly in JavaScript to parse the response they receive from PC. Horizon now doesn't support transaction meta, so it's probably the case when we cannot use it directly, but at least from RPC, it has zero problems with parsing.
Looks like George has something to say, but I can't bring him up on stage. There.
Oh, okay. Yeah, I actually didn't have anything to say. I think Orbit makes a good point, but I do think that a unified event stream is better for like your average dApp developer. Even though we can do all the indexing on the fly, it's probably more catered towards like infrastructure providers like Stellar Expert and Horizon. So this is still going to have value for people who are just interacting with RPC directly.
I mean, we've been using it to actually display transactions in Stellar Expert, Bido Wallet, Reflector, Refractor, everywhere. I'd say it's a universal approach that can be used everywhere. I'm not insisting on it. It just seems to me that transaction meta will be even larger after that, and it might have some duplicated data because of this.
Anyways, can you hear me well? Audible?
Yeah, I can hear you.
Yeah. Okay. Great. So I have a couple of thoughts on this. First, if the meta size increase is concerned, I think I don't know if we made it explicit anywhere, but I think this should be optional for the most part. At least I don't see a good reason for not making the events optional. So I don't think, and the same goes actually for the ledger changes. So ideally, you would be able to pick one or another, depending on what is your downstream processing, and use whatever suits you. Then regarding the library, I wanted to point out that, well, JavaScript is not the only language out there, but also there is like some nuance to, like there is very nuanced difference between ledger diffs and events, because events tell you what exactly has happened during the transaction, whereas ledger diffs tell you what was the state after the transaction. And I think it matters more for Soroban, but I don't know, it might have some interesting implications for Classic. I don't know if they're interesting to anyone, but It's just that the format of the events, like if you're processing something, you might be interested in processing something as a stream of specifically events, right? And not a stream of some data types that depend on the operations, like you can see from the library. Correct me if I'm wrong, maybe I'm missing something there, but this don't seem to me like this standardized. And the idea here is that, you know, if I wanted to track just the movement of the balance and I'm not particularly interested in the exact semantics of each and every stellar operation, what I could do is I could just ingest the event stream and track the balance for a given account, which I think may be interesting to some consumers. So yeah, these are just some thoughts on why bother doing this at all.
I think the argument regarding the event stream is pretty solid because this way the server, in this case RPC, handles the streaming itself and indexing and cursors and etc. So instead of working with transactions and parsing transactions, it can like really rely on these events. It's a solid argument. But my point is that I'm not proposing to use JavaScript everywhere. Maybe we can like port this to Rust or other languages and use it inside RPC, inside other applications. Instead of adding the data, we can like do it on the fly in the RPC itself, right? To regenerate these events because basically all described events, that's what we do with the transaction made XDR. That's something we already do. So maybe it's just one of the options instead of extending the XDR itself again, because to me it looks already pretty large. My subjective opinion on this.
But again, if you could opt out of emitting events, would that solve your issue with the size? Because like I think besides the size concern, I feel like the suggestion of let's put a common implementation somewhere, we are just suggesting, well, why don't we put this common implementation right into core? I don't think it makes a huge ideological difference, and I think it does make something easier to maintain and to ensure that they work correctly from the core side. Yeah, especially if we are doing protocol changes. So yeah, and just for the size concerns, I totally agree, and yeah, I think we should make this. So I don't know if you have any strong arguments, but I feel like we are more or less on the same page here in terms of standardization. Because I guess just seems to us that putting it into core kind of makes sense.
Yeah, and the standardization, it sits inside the narrative of everything being a contract. So I think like that's what's beautiful about this is that you know, today we have, you know, classic operations, and then we have everything that happens on Sorbin, and the result of those things looks pretty different. But as a result of this work, we're moving towards this future where actually everything that just happens on classic looks exactly like a contract that's executing. And, you know, all assets actually do have a contract that's reserved for them. They have the stellar asset contract. And so the events are just going to look like everything that happens with assets, no matter if it's classic or anything like that. It just looks like a contract, which is also much more similar to other ecosystems, other like blockchain ecosystems as well. So there's that familiarity for everybody about how this works versus, say, Ethereum and other things.
Yeah, and I'll make sure to clarify in the cap that nothing's being removed from meta, and this will be optional. That's a good point, Dima. I mentioned the config flag for transaction meta before, but I'll go into that in a little more detail. Are there any other questions?
I didn't quite catch if we have made any final decision on memos.
Like what we talked about like 10 minutes ago.
Wait. What is the final status? Because maybe I've lost it.
Yeah, so we're in the context of this cap, we're forwarding the Muxt account information right into the addresses. But for memos, we still need to explore what Nico mentioned earlier. Like, so there's nothing finalized there, but we are going to go look into that.
Right. So there is no final decision. Okay, I was just
No.
afraid that I kind of missed it. Okay.
Yeah, no.
Yeah, I'm not sure if we want to discuss that more, because it's not actually, nobody's actually written like a formal. This is how we would propose an alternative for it to work. I mean, I could say something right now that I think aligns with what Nico was talking about, but I don't know if we want to just.
I think it'd be valuable if we actually get something written down and then present it in a future meeting, because I know we have 30 minutes left and Dima has a couple caps to present. So that's probably more valuable, right?
Great.
Yeah.
All right. Go ahead, Dima.
Okay. Yeah. Great. Yeah, I don't actually mind spending more time on the events if necessary, but if you're done, we can go to cap. At 63. So this is basically a cap that mostly changes the transaction set, but it does so in a pretty interesting way. So as you may or may not know, also a hassle you need to go through with footprints in Sorbonne transaction is done for a good reason. And this reason is being able to run the transactions in parallel, because if you know your footprint, we know that you don't have a data dependency between two transactions, and you actually can run them in parallel without worrying about any synchronization. So given the footprints, in theory, today, what you could do is you could write your own version of core application logic that takes the transactions and partitions them somehow into threads that run parallel from each other. But the issue with that is that there is no good boundary on how much time is it supposed to take. For example, if you take 10 transactions without data dependencies, you could run them in 10 threads, and they would, for example, take 10 milliseconds after synchronization. Or you could have the same 10 transactions, but all of them dependent on some ledger entries that have been updated, and thus you cannot schedule them into 10 different threads. You would run them in a single threaded fashion, and in the end, you will spend not 10 milliseconds, but 100 milliseconds to apply all those 10 transactions. So basically, since protocol doesn't do anything currently about parallelization, there is no good way to schedule the transactions in such a way that it takes some bounded and expected. Well, there is still an upper bound on the runtime, but this upper bound varies wildly, and it's not good if ledger may close both within 100 milliseconds or within like 2 seconds, for example. Which is why we are doing this cap 63, which solves exactly that problem, which is given a set of transactions, come up with a transaction set data structure that guarantees certain time for applying these transactions. With a caveat, of course, of that time being both time and modeled instructions, and not, of course, both time clock time, because we kind of cannot tell it beforehand without running the contracts, but we hope that our cost models are good enough. And another caveat being that you actually should have a sufficient amount of physical cores to support multi-threading, because, well, again, if you have just one core, obviously it doesn't matter if you run 10 threads. There is some spam here. If you have just a single core and you wanted to apply transactions in 10 threads, obviously you will not get any performance gain because, well, transactions are purely CPU bound. So that's the motivation for this cap. And the way it works is that we define a new structure for the transaction set that instead of having a linear array of transactions, defines two levels of grouping these transactions together. And the first level is called stages. And I will talk about why stages and what does it need for in a moment. And then every stage consists of multiple clusters of transactions, and within the cluster, transactions generally may have data dependencies. So it is expected in this cluster to have data-dependent transactions that need to run sequentially. However, there are no data dependencies between the clusters themselves. And thus, since every cluster is guaranteed to be independent of every other cluster, what you could do is you could take every cluster and put it into a separate physical thread. And thus you can apply the whole stage in parallel with as many threads as you have clusters. Also, I probably forgot to clarify what we consider data dependency. It is when a single transaction has an entry in a read-write footprint, and then another transaction has the same entry in either read-only or read-write footprint. Which means that one transaction modifies the entry, another transaction either reads or modifies it. In either case, we need to sequence them because if we don't do that, then we will get non-deterministic results for any of these transactions. Now, why do we have this additional level of transaction grouping in stages? The reason is that if we just try to naively say, hey, let's just parse the put the transactions in separate threads, put them in transaction set, and that's it, then we may run into some issues with current traffic patterns. For example, imagine an Oracle contract, for example, right? And imagine it updates an entry at some key, and then there are a bunch of transactions that want to read the value from the contract, from this Oracle contract at that key. And thus we have data dependency on a single entry, but we have only a single write of the entry, but we have a lot of reads of the exact same entry. So what we can do with the stages is that we can put a write into one stage and then all the reads into different stages. And basically this introduces just a few barriers of execution into the transaction execution schedule. But it allows kind of efficiently work around these traffic patterns, and given smart enough, maybe not even smart enough, algorithm for actually coming up with this data structure, you can deal with a surprising amount of conflicts all at once without introducing any special scheduling and synchronization procedures. So basically, just have a few barriers in between the transaction applications, and this allows resolving a lot of the conflicts at the same time. Before diving deeper, I will read the chat for a moment and see if there are any questions at this one. Okay, the new adjust approach. Okay, so this tab itself just changes the structure of the transaction sets. It doesn't have any particular changes around how we which transactions do we pick at all. But what I can say is that the protocol specification remains such that that transaction application order is randomized. And I think in case of math manipulations, nothing changes from the current approach because for any arbitrage, you're probably going to have the data dependency, and data dependent transactions are applied sequentially, and we shuffle all the stuff that is being applied sequentially. So the transaction order is still hard to predict, and yeah, I don't think it's any easier to manipulate than it is currently, which is to say it's not impossible, but just spamming ledger is the arbitrage transaction, for example. Yeah, in terms of the system requirements, again, the CUP doesn't define them. I will talk about this in a moment. But of course, yes, if you want to run transactions in parallel, then well, you need to have a certain number of cores present on the validator. It's I guess a trade-off, like like that's horizontal scaling. So if we cannot use better hardware, then we cannot run more transactions. Related research, maybe I will think I already have the section on shuffling the transactions, so maybe sufficient, maybe not. Yeah. Okay. I see a question regarding the order, and let me actually go a bit deeper regarding how exactly things are specified. First thing is that protocol does introduce a new network configuration setting for the maximum number of clusters per stage, which roughly, well, not roughly, but basically maps to the expected number of cores that the network is willing to throw at applying the ledgers. If you have less cores, then it may take for you longer than expected to apply the transactions. If you have more cores, or at least that many, you should be good. And as all the network configuration settings, this setting will be modified by a validator vote. So, you know, some validators say that like, you don't have that many cores, they will not vote for this, and ultimately network can decide if requirements to run validators are too expensive or too hard to come up with. And also to make it clear, when we upgrade to protocol 23, this setting will be set to just 1, so without any parallelism allowed as a network setting. So in order to enable any parallelism, network vote would need to happen. Okay, then to the structure. Okay, I already talked through the specification of the data structure. The base fee and surge pricing will work in the same way as it works now, which is there will be a single base fee for the transactions. It is 100 stroops. If there is no surge pricing, and if there is surge pricing, which means like if there were transactions that we couldn't include in the ledger, but that were in the mempool, we take the fee of the cheapest transaction that we do include and use it as a base fee that everyone has to pay. Okay, and now again to the apply order. First, there is still a canonical apply order that is defined in CAP. So you still can apply all the transactions sequentially and arrive at the same result as you would if you're applying them in parallel. And similar to what we do now, we shuffle the things before applying them. First, we shuffle every cluster using the hash of the transaction set and hash of every transaction. Then we sort the clusters. We don't need to shuffle them, but we just sort them by the transaction hashes. And then we shuffle the stages as well. So again, like if two transactions are in different stages, one may happen before or after another one. That's kind of what we do for shuffling, and I think it's not significantly different from the current state of things. Yeah, I don't think it does anything specific to, again, it doesn't change the status quo for MEV on the large scale. Like, I think the best thing you can do is still just spam the network with arbitrary transactions. It is the issue we have now, and it persists. Like, the goal of this CAP is not to prevent these types of attacks, but it does not make it any easier to guarantee any particular execution order between two transactions. So yeah, I don't see like if you see something specific, like maybe maybe we can catch up async later. But I don't think there is any change to the execution order that is relevant for MEV. Right. Okay, so that's the kind of the simpler part of the CAP. So again, multiple threads to apply transactions in parallel. Oh yeah, the most important thing that I forgot to mention is that we limit the number of sequential instructions across all the stages, which means that for every stage, we look at the cluster that takes the longest time in terms of modeled instructions, and then we sum up these numbers across all the stages, and then we come up with some number of sequential modeled instructions, which are hopefully approximating the real runtime for applying the transaction set given n physical threads. For example, if the ledger limit currently is 500 million instructions, with this CAP, for example, if you set ledger max dependent TX clusters to, for example, 8, meaning you need 8 physical threads, and we keep the limit at 500 million instructions, we expect the ledger application time to be roughly a factor of 500 million virtual instructions, which is equivalent to a few hundred milliseconds currently, given our cost models. Yeah, so that's kind of the simpler part of the CAP. The trickiest thing is the GTL update semantics change. So all this data dependency stuff is very good and nice, but one thing that we, again, consciously did when launching Soroban is we allow extending the TTLs of the entries, even if the entries are in read-only footprint. And the reason for that is that, well, we expect TTL updates to be really prevalent And if we treated them as writes, there's a big chance we wouldn't be able to parallelize anything at all, because things would be just clumped together with all these clusters of, for us, contracts that happen to update TTL on the same entries. Which is why we decided that we actually can reconcile the TTL changes after running all the transactions without risking introducing any non-determinism. And this TTL update semantic exchange is doing exactly that. Changes how we update TTLs in such a way that changes to TTL done by transactions that only touch the read-only entries are not observable until someone actually writes this entry, or until we have finished applying all the transactions. Which is good enough to be able to actually run all the transactions that have the same key as read-only. You can run them in parallel and still arrive at the proper TTL value. And the algorithm proposed is pretty lengthy, but the gist of it is that if two transactions update TTL on the same entry, they both will see the initial state of the TTL of that entry, and will be charged the respective fee for that. So for example, if transaction A has a key in read-only footprint and updates TTL of some, say, XLM contract, right, by 200 ledgers, increases TTL by 200 ledgers, and then transaction B increases TTL of XLM contract by 100 ledgers, well, the transaction A will pay for extension by 200 ledgers, and transaction B will pay for the TTL extension by 100 ledgers. But what we will do in background is we will collect these TTL changes and only apply the maximum change out of that to the ledger, out of this to the ledger, which means that the XLM contract will be in the end extended by 200 ledgers. And it does introduce a bit of annoyance into how meta should be processed, which is unfortunate, but I couldn't think of a way that is both compatible with parallelism and doesn't require any changes in meta ingestion. And this change is that basically when ingesting the changes in TTLs from the meta, you should never decrease TTL. This is the only thing you need to do. It is documented in the CAP, and you'll probably make another announcement. But yeah, we kind of get around doing something special for the meta, and this seems like the minimum possible change. So TTL, like that you record in the backend, can never go down. But the TTL that you observe in the meta is correct. TTL change for the meta is correct in the context of a given transaction, meaning, as I mentioned before, that we'll charge the fee based on the changes that you observe in the meta. And this is kind of the gist of it. And there is, yeah, and I can talk a little bit about candidate value generation and then move on to question. CAPs don't typically provide a way of how to actually build the transaction sets, which makes sense. It doesn't need to be a part of the protocol. As long as it is valid, it doesn't matter how it has been built. But we'll likely implement a simple greedy algorithm described in the CAP. And the idea behind it is just to tag the transactions into the stages greedily, while ensuring we are utilizing the stages properly by bin packing from time to time. And the efficiency of bin packing heuristics is surprisingly good. So in the end, I think we can I did some benchmarks, and we can both pack the ledgers pretty efficiently, like utilize most of the instructions, and we can also deal with a decent amount of conflicts. Like if you have some relatively sparse clusters of conflicts, they will not cause any degradation in ledger utilization at all. And in order to have any real degradation, you need like some super interdependent transaction flow, which I don't expect to be happening in the wild. So I think this should be good enough, at least initially. And if we ever observe there are issues with that, there are ways to deal with that, both at the mempool level and the layer of building the transaction sets. I think that's all I wanted to talk about, just to present the cap. And now I will move to the chat and read some questions. Blog. Yeah, question from Nicholas about the meta changes for TTL. Emit net diffs for TTL, not emit one per transaction. Well, we still need to emit TTL diffs per transaction, I think, because they are an effect of the transaction. This is how we charge fees. And I'm not sure it is correct to just omit them. And whether we want to update meta, I have considered this. I am not sure it is necessarily a better solution. So basically, the alternative to what is proposed in this cap is, well, we could add yet another field to the meta that will explicitly output the TTL of every entry affected by the ledger, the final TTL for it after applying every transaction in the ledger. That's potentially a significant amount of duplication, unless we also kind of remove the changes per transaction. But I'm not sure if it is a good idea to remove the changes per transaction, because then, well, meta just has some entries drop that transaction has actually affected, which makes it tricky to debug transactions, for example, makes it tricky to understand your fees if you ever wanted to run the computation logic on this. So I'm sure we can omit the per transaction changes, but then I'm not sure if duplicating this data is necessarily making things much easier compared to just not decreasing TTL if you're tracking it. So that's my opinion. And I mean, you either need special logic for merges, or you need special logic for ingesting this new types of TTL entries, and you also need to kind of sometimes ignore the per transaction changes. I'm honestly not convinced if it is a good idea. And if you wanted it possible to only ingest the TTL changes after the ledger, then so that you don't even need to process per transaction changes at all, then basically we duplicate every TTL change in the ledger, which is, again, probably not very feasible. I don't know, Nick, if you want to talk more about this. Or we can continue offline. Okay, I don't see any more questions, and we actually have just 3 minutes left. So if anyone has any questions, please feel free to comment on the chat discussion thread. It is, yeah, I guess the TTL meta change is really the most controversial thing about it. Everything else is really non-controversial, I feel, because, well, we are just planning to include more transactions in Ledger, and we still shuffle them, so no changes for MEV. So, yeah.
Yeah, and one final thing, I'll say thanks for presenting, Dima. We forgot to talk about back to the unified events. One topic about how the SAC events have the asset name in the topics, but SEP 41 doesn't specify putting the asset name in the topic. So Lee is about to start a thread about this, so we can discuss it there. Yeah, Lee just posted the thread in the chat. Yeah, that's all we have for today. Thank you for joining.